Okay, a very good day to you. Today we are doing One Express chapter 3.3 and we're going to look at this concept of estimation. Now, in this chapter previously we've gone through approximation, and what do we do in approximation is we will need to round off at the end of a particular working. Why do we do so? So that we can communicate our ideas to other people in a very clear manner. We don't want too many numbers. We just want to approximate to roughly, maybe I just need 3-4 numbers to make sense of my calculation. Alright, so usually how do we approximate? We've learned that we can approximate into different places or different units. For example, approximate to the nearest thousands, approximate to the nearest tens or the tenth, for that, if that matters. And also we've learned how to approximate to certain significant figures, 5 significant figures, 1 SF, 3 SF, and so on and so forth. So this is approximation, to round off at the end of the working. Today we're going to do a little bit different. We're going to do estimation, and what are we going to do here is instead of rounding off at the end, approximation is to round off at the beginning to make our calculations much easier. Alright, so what is going on over here is that because instead of relying on calculators, we may want to rely on our brains. So by giving a good estimation, we can do mental calculations fast. Okay, so we've been doing this all this while. It's just that we haven't got a name for it. Alright, and the formal name over here is estimation. Example, let's take a look at this menu over here. Alright, it's the Starbucks menu. Let us zoom in. Right, let us zoom in into this. For example, I'm feeling thirsty. Alright, and I kind of want to have a vanilla sweet cream cold brew over here. Alright, and I think like my friend would want to have let's say maybe a grande cappuccino. Oh wait, okay, I'm blocking. A grande cappuccino. Alright, so for these two cups, right, roughly, we're going to need to pay $7 above and $7 here. So 7 plus 7, roughly I'm going to pay $14. And you see what I've done here? I round off first, and after rounding off, what I need to do is to add these sums together to get a rough figure of how much do I need to pay. Right? So this is what we call by estimation, is to do the rounding process first. Instead of using 690, 680, I'm going to get like 1370, I guess, and round off to 14, roughly $14. I can do that, but to round off first will make calculations much easier. Alright, so usually where do we round off to? We usually round to the nearest integer, the nearest whole number, or maybe if we want, we can get maybe like the nearest cents, or maybe like nearest 10 cents roughly. Yeah, so it really depends on the instructions of the question. Usually whole numbers will work fine. Alright, so without further ado, let us take a look at our first example from our textbook. Alright, we are back, and here we are in practice now 5 in page 83 of the textbook. Alright, and over here, let's take a look at question 1 above. Alright, so Ali used a calculator to evaluate 798 times 195 and obtain the answer 15561. Without doing the actual calculation, use an estimation to determine whether Ali's answer is reasonable. Then use a calculator to evaluate that is your estimated value close to the actual value. So let's take a look at this. We have 798, right? 798 times 195. Alright, so in order to estimate, we need to round off first. So over here, I'm going to write down my approximate sign. It is approximately equals to. Now, what number should I round off to make my calculation easier? So over here, we have 798, 195. I think the easiest number to round off to should be the nearest 100. Alright, so let us try getting this to maybe 800. And for 195, we get it to 200. And let us multiply these two numbers together. So what is 800 times 200? We have 8 times 2 is 16. And 4 zeros behind. Alright, so what does this mean for us? What does this mean for us? This means that um, over here Ali got 15,000, but in fact we have 160,000. So technically speaking, Ali's answer is not reasonable. It is off by one digit, right? So so we say that Ali's answer is not reasonable, right? Because it is maybe 10 times roughly. Maybe you can say it is roughly 10 times 1 over 10 times of our estimated value. Right? So let's then the final part would be what do you call this? Getting the actual value, right? So for this case over here, let us take a look at the calculator and see what does it give us. So we have 798 times 195. Right? So the actual value, right? Okay, actual value. So it will be 798 times 195. This is going to be 155,610. Right? Okay, so if you were to compare this value over here and your 160,000 over there, alright, we say that what we estimated is overshot a little bit. We've estimated a little bit more. So we say that our number is an overestimate, right? So a term that we may use is that our value, right, is an so-called overestimate. Now, if let's say if we go below the actual value, we call it an underestimate. Okay, so yeah, so we can say that it's pretty close to the actual value. All right, considering the fact that Ali's value is so way off, like one digit off, it makes a lot of difference. Yeah. Alright, let's take a look at number 2 right there. Alright, so over here, number 2, we have estimate the following values without using the calculator. Then use the calculator to find the actual value. Alright, let's take a look at A. We have 5712 divided by 297. So what I'm going to do is now when we round off, right, we will probably need to round off to roughly the same order, or what we call the same number of SF, significant figures, so that it makes our calculation a bit more standardized. So for A, what I suggest is to round off to the nearest hundreds, right? So over here we have 5712. I'm going to approximate this, estimate this to be 5,700, right? And 297, I can round this off to 300 over here. So the rounding process starts right at the beginning. So 5700 divided by 300, I'm going to get maybe 19, correct. 19 times of 300. Okay? And let's take a look at the actual value and see what it is over there. So what is our actual value? 5712 divided by 297. We're going to get 19.23. So our value is actually an underestimate, but I would say it is a very close and very good estimate of this thing. Alright? So usually we do estimates for numbers which are close to the edge. For example, we have 297, which we can round off to 300 nicely. 5712 round off to 5700 nicely. Okay. When things happen, when we have 5 in the middle, the numbers in the middle makes it a bit hard for us to estimate. So that's where a lot of the debate comes from when we want to estimate halves. Alright, the next one we have square roots 63 multiplied by cube root of 129. Now when we talk about roots, we have addressed this earlier, right? Is that when we want to estimate roots, we will need to estimate them or approximate them to the nearest square number or the nearest cube number. And then that would be fair for us to do the square rooting or the cube rooting. So for the first example, 63 is not a perfect square, but 64 is going to be a perfect square. So I'm going to round 63 up to 64, and you can see that it's actually a very close estimation. 129, I'm going to round this off to 125. Alright, so what is the, it's going to be our perfect cube. So square root of 64 will give us 8. Square root of cube root of 125 is going to give us 5, and this will be equals to 40. Right? So let us take a look at what is the actual value, and I would say that the actual value is actually very close. Alright, so square root 63 times cube root of we have 129. So our calculator tells us that it is, oh, it is a times, right? Yes, it is a times. Our calculator tells us it's going to be like 40.105, right? So it is actually a very close approximation to the actual value. Alright, so with this we proceed on to question 3. The driving distance between Singapore and Malacca is 250 km. Your father drives around 80 kilometers per hour and asks you how long will he take to drive from Singapore to Malacca. Write down an expression you can use to mentally estimate the duration in hours. Alright, so with this, right, for question 3, now we're going to take a look at the speed formula over here, and a good way to remember the speed formula is to draw out the Bermuda triangle, right? So yeah, speed will be equals to distance over time, and for this case we are interested in looking for time, so we will need to take distance divided by speed, right? So the time taken will be equals to distance, right, divided by speed. Let me write this nicely. Right, so distance divided by speed. So what is the distance over there? The distance is 250 kilometers. The speed is roughly 80. Okay, fine. Okay, it's roughly 80 kilometers per hour. Now, so in order to divide this by a very good and easy way, we're going to like roughly match and find multiples or find things that relate numbers to each other. So instead of rounding towards like the nearest 100 and so on, we can also round off to the nearest multiple. So 250 and 80, I'm going to round 250 to 240, since it is a very close value to 250, right? So roughly 240 over 80, I'm going to get roughly 3 hours, right? Roughly 3 hours. So I think this is a very good estimation, and in fact it exceeds a little bit more than 3 hours, but this is what we get for this part over here. Okay? And so with this, we see 3 types of estimation. The first one is to estimate to the nearest units or nearest place. The second one is to approximate to the nearest perfect square or the nearest perfect cube when we come to square roots and cube roots. And for number 3, when we are doing a multiplication or dividing, especially when it comes to dividing, we round off to the nearest multiple of each other. Alright, so let us take a look now at practice now 6 over here. Alright, so we have practice now 6, and this involves conversion of money. Alright, conversion of money over here. So we have a pair of earrings costing 25,000 Indonesian rupiah. The conversion rate is going to be 1,000 rupiah to $0.095, right? So we have 1,000 rupiah, right, will be equals to this amount over here. Now, so when the question asks for us to estimate, right? We're going to do a very simple thing. Notice that our Singapore dollar is actually is in the zero, like the 0.0 something. So in order to what do you call this, to approximate this nicely, alright, I'm just going to like convert this 0.09 to a 0.1, right? So it will be roughly approximated, right? Roughly approximated to 0.1. Okay, so I will need to do this first, right? And the next thing that I would love to do, right? The next thing that I would love to do is to multiply this by 10. So if I multiply the left hand side by 10, I'm going to get multiplied on the right hand side by another 10. Okay, you see what I did there? Alright, so with this, can I find can I roughly estimate a pair of earrings costing 25,000 rupiahs? Right? So what am I going to do is, on the left, I multiplied by 2.5, if you can see, right? I multiplied by 2 times and a half, so to get 25,000. On the right hand side, I will need to also multiply 2.5. So 1 times 2.5 will give me $2.50, and this would be my final answer for practice now 6. Alright, so let us try, let us now look at exercise 3B, right? Right, and this is in, I think, 3 more pages, 87 if I'm not wrong. Okay, alright, let's take a look at question number 12. We have a table over there. Alright, we have our 32, 19, 18, 9 and so on. So we are going to estimate how much, right, the total amount of money that the shopkeeper have to pay. Right, so with this, right, okay, let me do this. Alright, so let me write down, you don't have to write down anything in this, okay, maybe you need to write down somewhere, but I'm just going to like make use of labels to like make my life easier. So I have my objects, I have my quantities, right, and I'm going to have my costs per item. Alright, and what I'm going to do is I will just fill in this table with the approximate value, and straight away I can use this to find, right, what is the estimated cost, right? So over here, and another table over here, I'm going to have my estimated cost, right? So I think it is useful to do a table when it comes to like handling a lot of data over there. Alright, so let me move this away, and let me move this up a little bit, and let me squeeze myself down. Okay, alright, okay, so let's take a look at what we have over here. So we have 32, we can round that off to 30, 19 we'll round off to 20, we have 18 round off to 20, 9 round to 10, 49 round to 50, we have 20. So this part is the rounding off part, yeah. 18 will give me 20, 52 roughly 50, and 11 will give me roughly 10. So the estimated cost would be 30 times 20, 600, 200, 1000, 1200, and maybe 500 over here. Alright, so last but not least, the total estimated cost, alright, it's going to give us over here, so 600 plus 200 plus, okay, 1000 plus 1200 plus 500, I think, okay, thankfully I'm not blocking. So with this, my mental calculation is going to tell me that I have 1000, 2500, so 2500 that I need to pay roughly, right? So there we go, right? And it's already in the nearest $100. Okay, so with this, we've come to the end of our the end of the 3.3 estimation, and you will need to do the exit pass on your own to test your understanding on this concept, right? So once again, let me repeat our uh, concept of the day. It is to when we approximate, we normally round off at the end, and when we estimate, we normally round off at the beginning. And the purpose of this is to make our calculations easier. So thank you so much. Have a nice day ahead.